Let me start with the polynomial, and then we will start the real. Okay, so I want the polynomials to have, and this is, let me add. Yeah, in the meanwhile, Hami, what do you know about the polynomial?
Yes.
Yeah, what do you know about the polynomials?
Uh,
Yeah, what do we mean by poly? Okay, so let me explain those concepts before, and then we'll start. So, is the screen visible to you guys? Yes. Is the screen visible to you guys?
yes.
Okay. This one is the first. Right. So, what is a poly? Okay. Okay. So, what is a poly? Right. As we can see that it is made up of two words. One is poly, which means one or more. Right. And nomial, which means that terms. So whenever we have one or more terms, right? So that would be called the polynomial. So this definition is based on the number of terms, right? So let's say that we have this term, right? So how many terms do this do this thing has? How many terms?
One.
One term, right?
One term.
So it has only one term, and let's say if I write something like this one. So how many terms are there?
Three. Two terms.
Three. So this one, and this one. So we have three terms, right? So on the basis of number of terms, the polynomial are defined in different ways, right? So whenever we have only one term, so this is called a monomial. And whenever we have, so on the basis of number of terms, how are the polynomials defined? Right. First, let's say that if we have only one term, so this is called monomial. And let's say that if I have two terms, right, so this will be called a binomial. Oh, so you are joining from the different device, Hami.
Yes.
Yes, Hami, are you joining from the different? Oh, okay. Yeah, what happened, Hami? You joined from the different device.
Yeah.
Yeah. So whenever we have two terms, so this would be called binomial. And whenever we have three terms, so this would be called a trinomial. Right. So on the basis of the number of terms, the polynomials are defined in different, right? So this definition is based on the number of terms, right? We can have a different definition also, so we will see about that later. But on the basis of number of terms, this is how the polynomial is defined, right? And when we have four terms, so this will be called polynomial, and so on. Right, so all these are the example of polynomials on the basis of number of terms. Okay,
Okay.
but
Yes, sir.
but we have some certain conditions, right? To have a polynomial, we have some certain conditions. So these conditions must have with you. So what are those conditions? First one is that a polynomial can't have negative powers, right? What do I mean by that? So let's say that if I write a polynomial like 3 by x squared plus 2x plus 5, right? So this is a trinomial, right? But is this a polynomial? What is the power of this term? What is the power? Yes, Hami, what is the power of this term?
Square, x square,
So
2.
this is in the this is in the denominator. So if I take this term in the numerator, so the power would be what? In minus, right? So
Yes.
if I have, so this is the simplification of these terms, right? You see
Yeah.
that what is the power of x in these terms?
-2.
Minus. We have a negative power in these terms, right?
Yeah.
But the definition of polynomial says that it cannot have negative power. So this is not a polynomial, right?
Yes.
So this is not a polynomial. So can you guys tell me about, let's say if I write by x cubed plus, let's say x square and then x5. So is this a polynomial, Hamid?
Yes.
This is a polynomial. How this is a polynomial?
Because it doesn't have negative powers.
What can you say about this term?
Sir, it is not
It
a
is not.
polynomial.
It is not a polynomial, right? But let us simplify. But you harm me, your answer was correct. But you have to tell me that how this is not a polynomial, right? Yes,
Yes.
Hashid, the answer is that we have to first simplify these terms, right?
Yes, sir.
So without simplification, we cannot tell whether this is a polynomial or not, right?
Yes, sir.
So the first thing would be that we simplify these two terms. So we have 3 into x5 plus we have x square and then x5. Right? So this 3 will cancel and this will become 2. So we have 2x square plus x to the power 7. Right? Now, what can we tell about these two terms? Right? This doesn't contain a negative power. Right?
Yes, sir.
So now
Yes.
we can, yeah, now we can confidently say that this is a polynomial. Right? So this is the first condition of a polynomial, that it cannot have negative power. Is that clear to you guys?
Yes, sir.
Yes.
Who joined? Shreyesh. Oh, Shreyesh, who joined? So yeah, we just started the second chapter, Shreyesh. Okay. Yeah. So Yeah, Shresh, hello. Are you there?
Yes, sir.
Yeah, so we just started the second chapter and I was talking about the polynomial. So let me quickly recap this for you that polynomial are, it is made up of two words. So one is poly, which means one or more, and the other is nomial, which means term. So whenever we have one or more terms, so that will be called a polynomial, right? But we have different classification of polynomials. So if we have one term, so that would be called a monomial. Okay. And whenever we have two,
Uh, Sir,
yes, yes.
actually, I need a favor from you. Actually, is it necessary for me to join the backup class as I am not feeling well and visiting to medical store for the checkup?
Yeah, yeah, yeah. So it is not necessary. It is not necessary. So if you want
Okay, thank you,
the,
sir.
yeah, yeah. Who joined? Yeah, you are going for to the market share. Yeah, go. Okay. So Amar has also come. Yeah. So you guys are joining late, right? I have to repeat all these things again, Amar. Okay. So Amar, you were not there in the class. Yes. Hello, Amar. Can you hear me, Amar? I will. Yeah, I will move on and then I will repeat those things again. So the second condition is that a polynomial cannot have fractional powers. Right. So whenever you have these kind of terms, so let's say that this is this is defined like this. So let's say you have 3x to the power 2 by 3 plus 4x plus 5. Right. So you have these three terms, and you see that the power of this term is a fraction. Right. So will this be a polynomial?
No.
No, sir.
No, right. So this is not a polynomial. So these are the two conditions that we must follow. Right. Whenever the terms are given, and when you find after simplification. So after simplification, you find that there is a term which has negative power, or there is a term which has fractional power. So then we can confidently say that those are not polynomials. Okay. And if they don't have any fractional or negative powers, then we can confidently say that they are polynomials. Is that clear to you guys?
Yes.
Yes, sir.
So this was based on number of terms, right? Now on the basis of power, right? So we define a concept which is called degree of the polynomial, right? So on the basis of the power on variable, we defined the degree of the polynomial. So it is defined as the highest power on the variable, right? Why am I saying variable? So let's say that you have this kind of a polynomial. Let's say this is 3x squared plus 2 power 5 plus 6, right? So you have this x variable, and all these things are constant, right? So we only see the powers on the variable. We don't care about the powers on the numbers, right, guys?
Yes.
So what is the power of variable in this term?
2,
So 2.
Power is 2, right? And in this term, what is the power on variable?
5,
So this is not a variable. 2 is not a variable, right? So I can write this as x to the power 0, right? Because I can write any number as product of 1. So I can write 2 to the power 5 as 2 to the power 5 into 1, right? And I can write 1 as x to the power 0. So anything to the power 0 is what? 1, except 0. 0 to the power 0 is not 1. But anything other than 0 to the power 0 is 1. So what is the power here?
So 5.
No, power on the variable. We are talking about
Oh
the
yeah,
power on
it's
the
a
variable,
0.
right? And then we have this one. So what is the power here?
So 1.
It's 1, right? So highest power in this polynomial is what? That is 2, right? So the degree of the polynomial is defined as the highest power on the variable. Variable, a word is important, right? We don't bother about the power on the numbers. So highest power on the variable is 2, which means that what is the degree of this polynomial? Yes, what is the degree of this polynomial? This is 2, right?
yeah,
So this is the degree of the polynomial. And let's say that if I write a polynomial like this, so I write 3x squared, or let me write this as 3x to the power 4. Okay. So this is the polynomial. So how many terms does this polynomial contain? How many terms are there?
So 1.
Only one term, right? So we have only one term. So this is a polynomial. This is a monomial. But what is the power on the variable? So the power on the variable is 4, right? So this is a monomial having degree equal to what? Degree is 4, right? So this is a monomial and the degree is 4. Is that clear to you guys? Is this clear?
Yes, sir.
Yeah. So now on the basis of degree of the polynomial, there are certain classifications of the polynomial. Okay. So on the basis of degree of the polynomial. Okay. So if I have degree equals to, and this is the polynomial. If I have degree which is 1, so this will be called a linear polynomial. Okay. And if I have a degree which is 2, so this will be called a quadratic polynomial, right? And if I have degree equals to 3, so this will be called a cubic polynomial. Okay, so this is the classification of polynomial based on the degree of the polynomial. One was the classification which was based on the number of terms, right? So on the basis of number of terms, there is some different classification. And on the basis of degree of the polynomial, we have different classification of polynomial. Is that clear, guys?
yeah,
Yes, sir.
Yeah. So let's say that if I write a polynomial like this, so 2x cubed plus 4x what is the degree of this polynomial?
So 3.
3, right? Absolutely correct. So 3 is
So
the
it's a
degree
cubic
which,
polynomial.
so it's a, yes, absolutely correct, Harsh. So cubic polynomial, right? And let's say if I write a polynomial which is x plus 3 and x plus 5, right? So can I tell about the degree here?
So we have to simplify it. We have to multiply.
Absolutely. Yeah, absolutely right. So we cannot tell anything about the polynomial before we simplify this. So we have to, or after, so we have to simplify these two terms, right? So how can we simplify? So x is multiplied with x plus 5 and then plus 3. So plus 3 multiplied with x plus 5, right? So we get x square
X
plus
square plus 5x plus 3x plus 15.
plus, right? So this would be x square plus 8x plus 15, right? Now we can
Yes, sir.
certainly tell. So now
It's
we
a
can tell
quadratic
that,
polynomial.
yeah. So degree is 2, which means that this is quadratic polynomial, right? So first we talked about the number of terms, right? We talked about monomials, we now talked about the binomial, trinomial, and so on. So this was based on the number of terms. And then we talked about the degree of the polynomial, right? And degree of the polynomial was highest power on the variable. So on the basis of the degree of the polynomial, we talked about linear polynomial or. So we talked about linear polynomial, quadratic, and cube. So let's say that if I write a polynomial like this, so 3x plus 5. Right. So what is the degree of this polynomial?
So 1
1, right? So this is degree is
linear
1.
polynomial.
So this is absolutely correct. So linear poly, right? And how many variables are there?
One,
One.
two,
So we have yeah. So only this one is variable, right? How many?
not three and okay.
3 and 5 are numbers. They are constant, right? So only this one is variable.
Okay.
So this is a linear polynomial in one variable, right? And let's say if I write 3x plus 4y plus 3, right? So what is the degree of these polynomials?
So 1, and
Again,
it's
yeah,
linear polynomial in two variable.
yeah. So this is a linear polynomial in two ways. So we will talk about these kind of polynomials in the third chapter, right? So let us get back to the polynomial part again. Okay. Yeah. So this was about the degree and classification of polynomials. Now what we want is that we want to have the solutions of the polynomial, right?
Yes.
So to have the solution of the polynomial, let's say I have this polynomial, right? So I have this polynomial which is 2x cubed plus 3x plus 5, right? I have this polynomial. And I want to have the solution of this polynomial. So what I do is that I equate this polynomial equal to 0, right? So up to this point, this was a polynomial. And as soon as I equate it this with 0, so then it will be changed to equation. Okay. So if I equate it with 0, so whatever the value of x I get, whatever the value of x I get, so that is called the zeros of the polynomial. right? These are the solutions of the polynomial. So whenever I equate the polynomial with 0, right? So this will change to equation, and then whatever the value of x I get, so this will be called zeros of the polynomial, right?
Yes, sir.
So okay, so before I talk about the zeros of the polynomial, there is a relation between, so there is a relation between the degree and zeros of the polynomial. Okay, so what is the relation? So if I have, let's say I have this equation, 3x squared plus 5x plus 7. So this is this is the polynomial that I have, and the degree is how much?
2.
Degree is 2, so this is a quadratic polynomial, right? This is a quadratic polynomial. But what I do is that I want to have the solution. So I equate it with a 0. So which means that 3x square plus 5x plus 7 equals to 0. So now this has become an equation, and it will be called a quadratic equation, right?
Yes, sir.
So this quadratic equation will have two zeros. Okay. So this quadratic equation will have two zeros. So can you guys see that the degree is 2 and the zeros are also 2,
So,
right?
so if the degree is 3, then the zeros will be 3.
Yeah, absolutely right. So this is the relation between the degree and zeros of the polynomial.
Okay.
So whatever the number of the, yeah, so the number of, or let me, number of the zeros of the polynomial, this will be equal to the degree of the polynomial, right? So as Harshit said, that this is equal to 2, right? So this is the quadratic equation. So we'll get two solutions of x. So let's say them alpha and so these are the solution. And if I put alpha in this px, so what I will get? Yeah, if I put alpha in place of this x, so what should I get?
So, solution.
Yeah, so I will get 0, right? Because these are
Yes.
the zeros of the polynomial. So if I put back this alpha and beta in here in this polynomial, then I will get px equal to 0, right?
Yes, sir.
Yeah. So let us understand it by a simple linear equation. So let's say that px is 4x plus 7, right? So if I equate it to 0, this is E0, which means that I have this linear equation, right? So I have 4x equal to minus 7 and x equal to minus 7 by, right? Which means that x equal to this one is the 0 of this polynomial, right? So if I put
So,
x equal to minus 7 by 4, how much should I get?
so 0.
Right, so that is meant by, that is what we meant by 0 of the polynomial. So if I put 7 by 4, right? So this 4 cancels and we have minus 7 plus 7, which means, right? So this is what we meant by zeros of the polynomial. Okay, yeah. And these zeros are related with the degree of the polynomial. So whatever is the degree of the polynomial, So that would be equal to the number of the zeros of the polynomial, right? So let's say that I have this so what is this equation? Yeah, what is the degree of this equation?
3 and 2.
3. Degree is 3, which means that this is a what equation?
Cubic.
Yeah, if degree is 3, which means it is a cubic equation, right?
So that means it will have three solutions, right?
Yeah, so it will have three solutions: alpha, beta, and gamma. Right. So these will have three solutions, right? Whether those solutions are real, unreal, or not, we don't bother about that. For now, whatever is the degree, so the zeros would be equal to the degree of the polynomial. So is this part clear to you guys?
Yes, sir.
Okay. So now we will talk about the solutions. How do we solve the polynomial? So solution of the polynomial. Right. So in this chapter, we will talk about there are two methods. One is the graphical and the other one is the algebraic. So, but for now, we will talk about the graphical solution, right? Or this is also called graphical representation of zeros of the polynomial. Okay. So let's say that how do we define the zeros of the polynomial? If we are given this polynomial, so how do we define the zeros of the polynomial?
Values for which the equation becomes zero.
Yeah, so I just equate it, correct, absolutely correct, Harsh. So I just equate it with, right? Yeah, so this is how we define the zeros of the polynomial. So let us talk about the graph, right? So in the graph, we have two axes, right? So this one is the independent one, right? Let's say this is X and this one is the dependent one. This is Y, right? And then we define Y as function of X, right? So then we draw the graph. Okay. So you guys tell me that before we talk about the graphical representation, you guys tell me that what is the value of, let's say this is -1, -2, -3, -4, this is 1, 2, 3, 4, 5. This is 1, this is 2, this is 3, 4, -1, -2, -3, -4, -5. Right. So can you guys tell me that what is the coordinates of this point?
So that's -4 comma 0.
-4, comma 0. Right, absolutely correct. And what is the coordinate of this point?
-1 and 0.
-1, 0, right? And in here, this is 3, comma 0. And in here, this is 5, comma 0. Right. So
Yeah,
on this x-axis, which part is always 0?
So the y part.
the middle part.
Yeah, the y part is always 0, right? So y part is, how many y part is always 0, right? We have x and y, so x is changing, but y is always 0, right?
Yes.
So let's say that I draw the graph of px. So this is px, right? And the point would be what? Point would be x comma px, right? This would be the point. So this is x comma px. X. So this has some x part and this has some y part, right? So at these points, what is the value of px? So what is the value of px in here?
X comma 0.
Yeah, so x and px is what in here?
0.
0. So px is 0 at this point. What is the value of px at this point?
-1.
Px.
0, sir, because
0, sir.
the point lies at
Yeah,
x-axis.
yeah. So y coordinate is 0. Again, at this point, what is the value of px?
0.
0.
0. And at this point, what is the value of px?
0.
0.
So if the px is 0, so what do we call those points? Yeah.
Again, sir.
Yeah, if the value of px is 0, so what do we call those points?
Depend.
Just
Zeros of.
zeros of the polynomial, right?
Yes, sir.
So you see, whenever this graph cuts the x-axis, then px becomes 0. So then whatever the value of x I get, that will be called the zeros of the polynomial, right? So in here it is appearing that this -1 is 0, right? And in here it would be something -6 or something like that. And in here it is 2.7 or something, right? So at whatever, yeah, so when the graph cuts this x-axis at whatever point, so that will be called the zeros of the polynomial. Is that clear to you guys?
Yes.
So if I ask you that how many zeros are there for this graph, so by looking at by looking at this graph, right, you can see that this graph is cutting the x-axis at these points. So at these
Yes, sir.
points, my px is 0, so I can say that the zeros are 1, 2, 3, and 4. Is this clear to you guys?
Yes, sir.
Yes.
Yeah, so this is how we defined or we represent the zeros of the polynomial. So the number of points, the number of points, the graph of px cuts the x-axis. So those points are called zeros of the polynomial. Right. So this is how we define graphically the zeros of the polynomial. Okay. Any doubt up to this point?
No, sir.
No, sir.
Yeah. So we learned about the different on the basis of terms. We learned about the polynomial, which was monomial, binomial, trinomial, and then we learned about the degree of the polynomial. So highest power on the variable, that is called the degree of the polynomial, right? And on the basis of the degree of the polynomial, we define linear, quadratic, cubic, these kind of polynomials, right? And the important thing to remember about the polynomial was that it doesn't contain the negative power, and it also not contain the
Fractional powers.
fractional power. And after that, we talked about the solutions of the polynomial, right? So
Yes.
in the solution, we talked about the graphical solutions, right? So
Yes.
and we saw that whenever the graph cuts the x-axis, So that represents the zeros of the point. Is that clear, guys?
Yes.
Yes.
So this is all about the first exercise, right? So this is about the first exercise.
Yes. So
So
there are only two
now,
exercises for this chapter, right?
yeah, there is only, yeah. So there are only two chapters, two exercises. So one is about the graphical representation, and then the other is about relation between coefficients and the zeros of the polynomial. And we have a specific case, and that is about the quadratic equation, right? So we will talk about them later. As for now, let us complete this first exercise. Right. So so Amar, you are there. You are not talking. What is happening?
Yes,
Yeah.
sir.
So you were silent from the beginning. So okay. So any doubt, Amar?
No, sir, but like
Yeah.
um, the previously the this one the like I'm like is this
Yeah. Yeah.
I don't know if this is a different batch or not because I can't differentiate between
So this is a mixed
I
batch.
can't
This is a mixed batch. So we are
ah
starting from the beginning, right? All
okay.
the people, yeah, all the people will come.
So should I
Hami has just joined, so he is new, right? But all the rest of the people are from different batch. So Hashid and Amar, you are in the same batch, right?
yes, so that's what confused me.
Yeah, yeah, yeah. So this is for the backup class. So we are starting from this. Okay.
Ah, okay.
Yeah, yeah. So do you have any doubt from this class?
I know, sir.
Oh, okay. Okay, so let us start one exercise and then we will then we'll start about then we'll talk about the second exercise. So we will
So
keep this.
the questions in the exercise are much easier, sir. But the
Yeah,
previous year questions have very difficult questions.
yeah. So we will also talk about So we will also talk about those questions. You see,
Yeah, yes, sir.
so we have these kind of question, right?
Yes, sir. These
So
one only. These questions are a bit tough.
yeah, so you see, I give these question in the assignment, right?
Yes, sir.
So yeah, and we have also the other question is that relationship between zeros and the quarter. Oh, so that would be in the quadratic equation. Yeah, what is this question? I guess. This one. So eighth question, right? Eighth question is let me tell you. Eighth and the seventh one,
The fifth one.
fifth one. Okay, yeah, fifth one and these kind of this 11th one also, right? 11th one, 12th one. So these
So, but
questions are,
these types of questions are not there in the NCRT textbook.
yeah, yeah. So we will also discuss these questions, right?
Okay, sir.
But we will discuss these questions. You see, in the AP and in the whatever. So we talked about those different questions, right? Yeah. So in here we will also talk about with that chapter. Yeah. So in the whole NCRT book, this is the toughest exercise, right, guys? This is the toughest exercise. Very sad. Yeah. This exercise,
Easiest one, sir.
yeah, easiest one. Yeah. So yeah, so you guys see that how many zeros are. So this exercise is about. I don't know what is the purpose of this exercise. So we have only one question. So this could have been added in the second exercise. But
Yes.
So,
yeah.
so like
So
are we doing okay
yeah,
right?
yeah, Amar.
Nothing, sir. Nothing.
Oh. So in this exercise, they talk about only the number of the zeros, right? So Hami, I will start with you. So how many zeros are there for this graph for this px?
No zeros.
No zeros, right? So zeros, zero. and then Harshit joined, right? So Harshit, how many zeros? Sorry to
So
ask
one.
you these questions. Sorry to ask you these questions. Okay. And Amar, again. So how many zeros?
Three.
One, two, three, right? So three, and this is two, and this is how much? One, two, three, four, and then one, two, three. So this is this is the first exercise that we have, right, guys?
Yes, sir.
Yes.
Okay, so let me talk to the Learnivio team, right? Because from the next classes onwards, we will increase the timing of this class. But there are only few people, so we should not go ahead, right? The next exercise is about relationship between zeros and coefficient of polynomial. And this is only restricted to quadratic polynomial, right? Because cubic polynomial is not in your syllabus, but I will also talk about that. I will also talk about that, and yeah, because they can ask, because we have this is not given in your NCRT textbook, but they can ask you this question. So
Sir, division algorithm, is there topic there in our syllabus?
no, no. So yeah, in the first batch, I did the division algorithm, but this was not in your syllabus, so I restricted. So I talked about the division error. So this is not there. I talked in here something. Right. So in here I talked about the division algorithm, but this was not in the syllabus, so I skipped. So you see in here, uh, yeah. So this is a previous book, right? So this is based
Yes.
on the 22 and 23. So in that syllabus, we had the division algorithm, right? But in the 23, 24, this is not in the syllabus. So this is the easier. Yeah, so division algorithm, we know how the division occur, right? So we have a divisor, dividend, quotient, and remainder. So this division algorithm is based on that, right? But this is not in your syllabus, so we will okay. Yeah, so we will stop it here, and in the next class, so this backup class, this will happen on Wednesday. So on Wednesday, we will start from the second exercise. Okay,
Okay, sir.
because
So
Wednesday.
every week the same schedule as
yeah,
Monday and Wednesday.
yeah, same schedule. And
Wednesday, which at which time?
yeah, same time. So at 9 p.m. KSA, which is 6:30, 6:30. Oh, 9 p.m. IST, so 6:30 KSA. Okay.
Okay, sir.
Yeah, but you guys are here, so do you have any question from the previous classes? Hashi then.